Your game's hero needs a health bar, a name, and to know whether they've completed a mission. But how does the game remember all that? In the next few minutes, I'm going to show you the absolute bedrock of C# code that will bring your characters and worlds to life. By the end of this video, you'll be able to create and manage the core data for any character you can dream up. Seriously, forget the complex stuff for a moment. Mastering this is the key that unlocks everything else. So what on earth is a variable? The easiest way to think about it is as a labeled box, a little container in your game's memory where you can store one piece of information. You give the box a name, you put something inside, and that's pretty much it. You have a box named Player Score, and inside, you put a number. You have another box called Player Name, and you put their name inside. And why does this even matter? Because every single game is built on information that changes. The player's health goes down, the score goes up, your speed doubles when you hit a boost pad. Your position in the world is updating constantly. Without variables, none of that is possible. Your game would just be a static, lifeless diorama. These containers are the heart of all interactivity. They remember things, they track progress, and they define the state of every object in your game, from the hero down to the smallest enemy. Understanding how to create and manage these boxes is your first real step to becoming a programmer. Now, you wouldn't store soup in a paper bag, right? The same logic applies to our variables. In code, we have to tell the computer what kind of information we're planning to store in each box. This is called a data type. For today, we're just going to focus on the 4 most common data types you will use constantly in Unity. First up, we have the int. This is short for integer, and it's just for whole numbers. No decimals allowed. Think of your score, your ammo count, or the number of lives you have. For example, 100, 25, or even -10 are all integers. Second, we have the float. This is for floating point numbers, which is just a fancy way of saying numbers with decimals. This is absolutely essential for anything that needs precision. Things like player speed, a character's height, or timers that count down fractions of a second. When you write a float in C#, you have to add an f at the end, like 5.5f or 9.81f. That f is you telling the compiler, hey, I promise this is a float. Third, there's the string. A string is how we store text. It's any sequence of characters you can think of, as long as it's wrapped in double quotes. The player's name, a line of dialogue, or an item description, all of these are strings. For instance, Aaron the Valiant, or you have collected the fire sword, are both strings. And finally, we have the bool, short for Boolean. This one is the simplest of all. A bool can only ever hold one of 2 values, true or false. That's it. Is the player alive? True. Do they have the key? False. Is the game paused? True. Booleans are basically the light switches of your code. They answer simple yes or no questions that control the logic of your game. These 4, int, float, string, and bool, are the absolute workhorses of Unity scripting. You will use them in every single script you write, guaranteed. Enough theory. Let's see this stuff in action, because the best way to learn is by doing. Here in Unity, I have an empty game object I've named player. We're going to create a C# script to hold all of our players' data. I'll just right-click in my project window, go to Create, and select C# script. Let's call it Player Stats. Now, let's pop this open in Visual Studio. We see this default template code. We're going to declare our variables right here, inside the class, but before the start method. This gives them class-level scope, which just means they can be used anywhere inside this script. The syntax is simple: access modifier, data type, variable name, and maybe an initial value. First, let's create a variable for our player's name. We want to see it in the Unity editor, so we'll use the public access modifier. A name is text, so the data type is string. For the variable name itself, it's good practice to use camel case, where the first word is lowercase and the next one is capitalized. So, player name. Let's give it a starting value, 2. Aaron. The whole line looks like this. Public string player name equals Aaron. Next up, the player's health. Let's use an int since it'll be a whole number. Public int health equals 100. What about movement speed? That might need decimals, so it's a perfect job for a float. Public float move speed equals 4.5f. Don't forget that f at the end. And finally, let's track whether the player has a quest key. That's a simple yes or no. which is exactly what a bool is for. Public bool has quest key equals false. And just like that, we've defined the basic data for our character. We have a name, health, speed, and an inventory status, all stored in neatly labeled boxes of the correct type. So, why do we keep typing that word public? Let's save the script and jump back into Unity to see the payoff. First, we need to actually put our script on our player game object. I'll just drag the player stats script and drop it right onto the player in the hierarchy. Now, with the player selected, look over at the inspector window. Boom. Instantly, all the variables we declared as public have appeared right here. We can see player name, health, move speed, and has quest key, all with the starting values we set. This is one of the most powerful features in Unity. You can now change these values right here in the editor without ever touching your code again. I can change the player's name to Kara. I can buff their health to 150. I can slow their speed down to 3.2. But what if you have a variable you don't want someone to mess with from the inspector? This is where the private access modifier comes in. Let's hop back to our script. If we change public int health to private int health equals 100, and save it. When we return to Unity, you'll see the health field is just gone. It vanished from the inspector. The variable still exists and works inside the script, but it's now hidden and protected. In fact, if you don't type public or private, your variable is automatically private by default. As a rule of thumb, it's best to keep your variables private unless you have a good reason for them to be public. And a little pro tip, if you want a variable to stay private but still be visible in the inspector for testing, you can add an attribute called serialize field right above it. It's the best of both worlds. Okay, our variables are showing up in the inspector, but how do we know the game is actually using them? We need a way to print information out so we can see what's going on while the game is running. For this, our new best friend is debug log. The start method in our script is special. It's called automatically one time, right when the game begins. It's the perfect spot to check our initial values. Let's add a few debug log statements to print our player's stats to the Unity console. Debug log player name plus player name. Here, we're just combining a simple text string with our player name variable using a plus sign. Debug log starting health is plus health. Debug log movement speed is plus move speed. Now, save this and head back to Unity. Make sure your console window is open. You can find it under Window, General Console. Now, hit the play button. And there it is. The console immediately spits out the messages we wrote, pulling the current values from our variables. Player name, Kara, starting health is 100, movement speed is 3.2. Notice that even though health is private, the script itself can still see it and print its value. Debug log is an absolutely essential tool for peeking under the hood of your game. We've got one last concept for today, constants. Variables, by their very name, are meant to vary. Health goes down, speed goes up. But what about a value that should never, ever change while the game is running? Think of something like the value of pi or a core rule of your game, like the max number of players allowed. For this, we use the const keyword. A constant is like a variable, but its value is locked in and can never be changed by code later on. For example, let's say our player's health can change, but we want a fixed maximum health it can never go above. Back in our script, we can declare a constant for this. By convention, constant names are written in all underscore caps with underscores. Public const int max underscore health equals 100. Now, our script has a fixed reference for max underscore health. If we ever tried to write code that says max underscore health equals 150, our code editor would scream at us with an error. You can't change a constant. This gives us security and makes the code clearer, preventing us from accidentally changing a value that's supposed to be permanent. You might also notice that even though this constant is public, it doesn't show up in the inspector. That's because constants are burned into the code when it's compiled. They aren't meant to be tweaked from the editor. All right, let's do a quick flyby recap. Asterisk variables are the labeled boxes you use to store all your game's data. Asterisk data types like int, float, string, and bool tell the box what kind of stuff it's allowed to hold. Asterisk public makes your variables pop up in the Unity inspector for easy edits, while private keeps them hidden and safe. Asterisk debug log is your go-to tool for printing anything to the console to see what your code is really doing. Asterisk and const is for any value that you want to lock down so it never, ever changes. You've just learned the absolute backbone of scripting in Unity. Every fancy system, every character controller, every brilliant piece of AI, it's all built on these simple ideas. So now, it's your turn. Here's a mini challenge. Create a brand new script called Enemy Stats. In that script, create the variables for a basic enemy. I want you to give it a health value, some attack power, a name, and a boolean to check if it's a boss. Go on, give it a shot, and then post in the comments what variables and data types you chose for your enemy. Now that we know how to store information, what's next? In the very next video, we're going to learn how to change this data using functions and operators. We'll finally make our player take damage, collect points, and actually move around using that move speed variable. If this guide helped you out, do me a huge favor and hit that subscribe button and ring the bell so you don't miss the next part of our journey. And if you have any questions at all, drop them in the comments below. I read and respond to as many as I can. Happy coding, and I'll see you in the next one.